the case studies from our participants. So they all had wonderful projects that they presented. But today we are coming back to Nantucket because over the last 4 weeks we have been really digging into the context of Nantucket, understanding the climate issues, doing real groundwork on the three buildings within the zones that we had already decided. And so the three groups are going to present the findings of their work in each of their case study areas. So without further ado, we will pass the floor, but maybe Niles, you would like to say a few words before we begin?
Thank you, Rohit. I don't have much to say now. I look forward to saying a few words at the end, I think. But yeah, thanks to those of you who are here today. I can't believe it's been a month already. It's gone very quickly. I really enjoyed the presentations yesterday. Obviously, a lot of work's been going into your time here on the island. We're very eager to hear your presentations today about these properties and help us better understand what's going on, develop a plan, next steps, things like that we should be aware of. So again, no stress. Looking at this as a fun afternoon. I'm sure we'll have some questions, some good conversation, and really appreciate all the work that you've been doing over the last several weeks here on the island. So, thank you.
Thank you.
Yeah.
Yes, of course. We have a pleasure to present as a first group, and it's zone number 1, and it's Sloan, Fatiha, Abdul, and Magdalena. Do you want to say just one word about you?
Hello, I'm Sloan Below, and I work for the New York State Office of Parks, Recreation, and Historic Preservation, and I'm trained in building conservation.
Hello everyone, my name is Fatiha Pauline. I am from Bangladesh. I am a conservation architect. I run a research organization called Perceive. It's a pleasure being here.
Hi everyone, my name is Abdulmajid Abdul Jabbar. I am from Saudi Arabia. I work in conservation project. My background is in civil engineering, and it is a pleasure to be here. Thank you.
And my name is Magdalena Skarżyńska from Poland, and I work in Polish Center of Mediterranean Archaeology, Warsaw University. Today we have the pleasure of presenting the results of this 4-week international course organized by NHA, ICROM, and ICR-ICC. And I think that on behalf of all participants, I would like to express really our great gratitude for this intensive and inspiring 4 weeks, for the welcoming atmosphere created by the unique personalities of the main instructors, and for the rare opportunity to experience a really perfect blend, deep expertises, practical learning, and really great enthusiasm for heritage conservation. So thank you so much for that. This program brought together 11 heritage professionals from around the world and combined online lectures, expert discussion, and hand-on work on Nantucket. And this group work focused on 3 study zones, and each of these zones, including selected historic building, analyzed in terms of their heritage significance, material condition, and vulnerability to climate change impacts. We will start from zone number 1. This is a small outline of this, what you will hear in the next 20 minutes. In introduction to zone. Zone number 1 is located between the oldest house and the Candle Factory, extending from the historic town center toward the ocean. It's a transitional area where Nantucket's early domestic and later industrial heritage meet. The zone connects inland residential plots with the coastal edges and offers direct visual and physical access to the sea. Because of its location, it reflects the long history of interaction between the island's community and the maritime environment, from early settlements to the walling and candle making industry. And here you can see that these two main points of our zone have really a lot of differences, even in a location. So oldest house, ground elevation is more than 10 meters, and it's 800 meters away from the coast. And the Candle Factory ground elevation is not even 1 meter, and to water we have only 130 meters. And now we will start investigation, and in the beginning of conservators' work, it's like that we need to be detectives a little bit. So I will start from a general description, and each step it will be deeper analyzing all structure of building which we have on this area. And I will start from the oldest house, but our case study is a place which you can see here, so it will be Candle Factory. So oldest house was built in 1686. About topography, I said these two words. If we will analyze a wind, due to its elevation, it always has a wind blowing around and has a possibility to affect by storm. Sunlight and heat is absorbed on all facades, and there is no agented structure of a tree nearby. And there is no water near to this house, but what is important that there is a lot of vegetation. If we analyze a drainage system, the building site is a well drainage due to natural surface and gentle slope. And right now there is, if we are talking about a site maintenance, NHA it's the owner, and we had a visit in this house also, so we know that after times when this house was ruined, right now there is a kind of place to visit with a historical part. The Candle Factory was built in 1846, so it was just after fire which take place in Nantucket. General analysis that drainage, the building site is mostly surrounded by impervious surface and indicate drainage. It's located in a really commercial zone. Also, NHA is owner, and what is important in this 1929, NHA start a renovation, and then this building change a function and start to be a museum. If we are talking again about some aspects which we see right now, the close proximity to the sea and accumulated stormwater from other neighborhood makes it more vulnerable for flooding, storm, and rising sea level. If we are talking about the vegetation, it's not so rich like around the oldest house, but still we have one tree on a north side and also few on the south side. As a detectives, we check history of this building to know what kind of rebuilding was during this long time of using. And what is really interesting, Abdul found some maps which are really, really good, showing that from the beginning this building was just like alone, and from 80s some new buildings start to build around. So right now we have a situation that from south and west part of this building we have another new buildings. And once again, some timeline to analyze some repairs and rebuildings here. So you see on this timeline one important moment, this opening of Whaling Museum, but also analysis of it can help us to understand a structure of this building and to think about it, why we have some rebuildings in each places. I think that thanks to this introduction, we can see that this building has a really rich historic value, and we choose also architectural value as the most important for us. And with attributes, we can find, of course, original brick industry structure from the mid-19th century, historic association with whaling industry, location in the former industrial district, and as an architectural value, these are similar things, but brick masonry facades, structural iron tie roads and timber trusses, and symmetric facade composition and proportion typical of industrial architecture. We are going deeper in our analysis. So right now we would like to look closer at the material of this building. So we have a stone water table foundation. External walls are red ceramic brick, originally lime mortar joints, secondary cement base repointing, which we saw in some places still. Decorative iron star shaped, so it will be other material, metal one. Also, we have some wood as a structural frame. Roof right now, it's after rebuilding in 2005, around 2005. So we have bituminous membrane, a slate roofing. Also, we have windows, so we have a glass and wood. And right now we need to analyze how all of these components are playing together. Here are illustration, each facade about materials. And here there is an analysis of damages which we found on each facade of this building. So we have this kind of degradation as a salt deposition, surface flaking, biological grown, black stains, cracks, cement base mortar joints, loss of cohesion in stone section, and also some cement plinth band. And most of these degradation are on every facade, but some of them, for example, biological grown, are typical from the lower parts of the building, but also here you can see that on the east facade, there where we have trees, then there is a bigger this biological grounds. And we decided to analyze each of element. We observed condition, but also we made a next step. So we analyzed causes of this deterioration. So for example, in a North brick wall, which you know that right now is under conservation work, we see a lack of structural bracing. Of course, it was before conservation works, because right now we couldn't make this kind of analysis. Reduction from 3 to 2 witness above second floor, later window. Right now, these windows not exist, so it was rebuilding. Age-related decay, exposure to high wind loads, and corrosion of abandoned iron steps. And east and south walls, it's a stress concentration around window openings, long-term material fatigue, water infiltration, and weathering, so wind, salt, air, freeze power. And we analyze each of element of this structure. And here you see again an illustration of that, and especially interesting is this south wall, because we have some photos before conservation works, and you can see here really a big crack in one of the corner, but also some reparation of this crack. So we see thanks this that it was a problem from a longer time. And here is a next wall, and also with these black stains, these biological films. Also, this wall was really interesting for us, because here we see that on the lower part of a wall, there is water and really big lack of joints. And also, this is exactly this wall which you can see here right now. So you can see that even if we are inside, these are similar types of degradation. And right now you can be a detective and analyze all of these degradation elements. On this course, we love tables, so here we analyzed some causes, but we are doing next step. So we are going to diagnostic of these causes. This is next table where we have a question. What do you want to learn from the fact that these are cracks, these are white staining, etc.? We have some hypotheses, but we need to check this hypothesis. So we're starting from field investigation, and we choose for our investigation architectural and structural survey, visual condition survey, material stratigraphy survey, and this we already do part of it because it's, for example, a mapping of elevation. We can use portable microscope to some stratigraphic survey. Apart from that, thermography will be really useful, and we can use thermal camera here. And if we want to make a next step, it could be even be a ground penetrating radar to detection of voids, buried elements, and foundation deep, and also endoscopic inspection to see what we have in voids between bricks, for example. Next step, these are laboratory analysis. So after field investigation, we decided we would like to make some laboratory tests, and we choose just each material and what we want to check in this material, and we choose methods. So we have a brick. We want to access the mineralogical composition, porosity, salt contamination, and overall degradation mechanism of the historic Mansouri. And as a methods, we choose petrographic analysis, scanning electron microscopy, X-ray diffraction, X-ray fluorescence, FTIR, but also chromatography. In mortar, we want to identify binder type and proportion, degree of carbonation, compatibility with the original Mansouri also, and the presence of salts or secondary compounds. And always this kind of test is good to start from just optical microscopy, so a thin section, also X-ray diffraction, FTIR, X-ray fluorescence, thermogravitical analysis, and for this mortar it will be really good also to testing a salt. And here these are methods also to metal and to wood. And right now, next step will describe my friend Fatih.
Thank you, Ma'am. So after the field investigation and laboratory testers, we tried to put a monitoring plan correlating the site and environment. For example, the environmental monitoring plan should address adaptation strategies such as managing groundwater, landscape, and microclimate that correlates with the data we found from our previous investigation. And here you can see, apart from the existing sensors on the north wall, exterior side, and in the west wall, interior side, we also need sensors to be added on the exterior of west wall, where Magda just shown the cracks here. And also we want some crack monitoring also in different locations. For example, on the south wall and also on the east wall here. As from the previous analysis, we also find that the building is really susceptible to high wind pressure due to the history of hurricane in this island. So we also want to put some weather station to analyze the wind pressure, wind velocity, and also the wind direction. Reviewing existing dataset for temperature, relative humidity on different time of the day and in different season, especially from the month of August, September, and October, considering the history of hurricane is needed. So we need to analyze the existing data in different time of the day, weekly basis, and in different seasons, so that we can assume the potential hazard and risk on this building. Also, from our analysis, we understand that the top of the building is mostly exposed to wind gusts. The chimney and the roof could become unattached or damaged. If the roof becomes unattached, it could leave other elements of the building exposed. For example, we are sitting in this room and here is the museum. So if we don't have the roof, so everything will be exposed and extremely vulnerable due to the weather conditions, including the brick walls, interior structure, and everything inside. If the storm or hurricane cause flooding, the basement and the masonry at the bottom becomes also vulnerable. Some mechanicals have already been moved to higher level. As you can see from this picture, previous attempt to restoration of the roof and also the chimney is affected. From the climatic scenario projection, we identified a primary hazard and also some related secondary hazards. As you can see here from the previous storm called Edna in 1954, these are the pictures during that hurricane. Nantucket has a severe wind factor risk based on the projected likelihood and speed of hurricane, tornado, or severe storms wind impacting it. It is most at risk from hurricanes. There have been like 10 recorded wind events in Nantucket. The most severe, as I mentioned earlier, was Edna in 1954. It was recorded as a Category 3 with 1 minute sustained wind speeds and up to 127 miles per hour, and 3 seconds with wind gusts up to 163 miles per hour. If an exceedingly rare wind storm occurred once in a 3,000-year storm event occurred today, it could cause wind gusts up to 157 miles per hour to reach Nantucket. We also experienced the last storm here in Nantucket, and you can understand the severity of the wind pressure here. A hurricane, the severity has 1% chance of occurring at least once over the next 30 years. In next 30 years, an event of the same likelihood would show increased wind gusts of up to 157, it can increase up to 175 miles per hour. So the next part will be described by my friend Abdul.
So after we study the previous and historical data of our primary and secondary hazards, or primary and also the study of the projection and the expected scenarios on the medium and worst case scenarios, we tried to link the effect and the impact on our building, starting with analyzing the vulnerability and exposure to these climate hazards in our building. So just to illustrate, to clarify, the primary hazard are the storm and hurricane, and the secondary high wind, flooding, and the erosion. So the elements that are more exposed will be the masonry and the south east corner and northeast corner, and also the north, south, and the east walls. They are facing directly the shoreline, and also they are on the way of the wind movement and the windway from northeast. Also, we have identified the exposure of the roof and the mortar brick, the wood, and the wind glasses, and the linkage between the links. There is a crack that are more vulnerable. And also, we study the surrounding area. It is close to the sea level, and also the elevation of the house is only 0.9 meters from the sea level, and the distance from the shoreline is only 130 meters. After that, we identified the sensitivity, the structural sensitivity and vulnerability. We conclude that the north wall is vulnerable to storm because it's showing sign of movement. Also, the foundation, there is a possibility of vulnerable due to cracks that could be caused by the movement of the rigid building. Also, we have identified the lime mortar have shown somewhat of powdery and sensitive to weather exposures. Also, we have noticed like different type of mortar between the brick on different part of the wall. So some of them are cement mortar, so used in many locations, and that increased the brick vulnerability and also increased the unhomogeneity between the part and the material that used. For the non-structural, we can see the museum collection. It's facing vulnerability if those structural have impacted, and also the surrounding area, the trees and the planting around are very vulnerable for this hazard, and often the profited trees fall onto the building during the storms. After that, we identify the gaps in the adaptive capacity linked to the local management response. We can see that the road is expected to permanently underwater in the future based on the scenarios we analyzed, and also a great deal of planning will be needed to be done to prepare, and this will involve many levels of participation from government, non-government organization, and also citizens, and also to eliminate the and decrease the vulnerability. The last part in the analyzing of vulnerability and exposure is the linking of the local environment and previous intervention and their impact on the building. We reached so many items, and we concluded in these 4 items, which is basically the island is a sandbar, and because of this, it is inherently susceptible to storm and hurricanes, and also the historical urban exposure and limited vegetarian buffer zones increase the storm exposure. Also, past cement-based repairs reduces the mason breathability and accelerate the salt damage. This slide just to remind you of the impact that we previously identified, the bludgeoning in some of the area, the cracks between the window is all over the wall sides on the building. After that, we started to look on the projection and the future data and the expectation for the increase in hurricanes and the windstorm and the intensity of that hazards. So as we just explained, the hurricane is remaining the most critical threats, and category 4 to 5 event could double in frequency by 2100, reducing gusts up to 175 miles per hour, and historical record shows like 10 major wind event future storm may raise gust speed and wave surge highly by 20%. So we identified like what would be the increase in exposure, and we came up with that the top of the building is the most exposed to the wind gust, and the roof could become unattached or damaged entirely. Also, if the storm or hurricane caused flooding, the basement and the masonry at the bottom becomes very vulnerable. In the long-term effect, there will be increase in the wind speed. It is expected to have high impact on the roof and the building, as I just mentioned, and also increase in the hurricane intensity will cause more deterioration to the building element by increasing the erosion and the ground, raising the groundwater level, and this will increase also the soil pressure and potentially cracking the masonry. So if we have soil pressure from one side of the building and the other is lower, and this is one of the study, one of the monitoring, we noticed that there is change and irregular in the water level between the side of the buildings. This causes soil pressure and potentially crack in masonry and shifting the foundation. Increase also in the mold and the microbial growth, colonize and wall cavities. Also the wooden beams, windows, and the increase in hurricane intensity might cause like uncalculated loads on the building that lead to partial or full destruction of the building element. Also, we start to analyze this impact on the value and attribute on the and their effect on the building. We started to go through the structural and the material integrity, and it is basically increasing in the frequency of the cause of deterioration of the building envelope and the high velocity winds and associated debris impact and weakening the roof joint, timbers, framing, and windows and the winding assembly. The combination also of the wind driven and the rain salon will intensively masonry erosion and metal corrosion and moisture penetration. Also, it will have impact on the non-structural attribute. I will not go through them one by one, just to highlight it here, and also the symbolic and the historical value by losing those elements of the building. Also, the visual and aesthetic, what we just showed, the stains and the erosion part, it will be affected and impacted, and also the community value, basically, it will limit the use of the building if it's got more and more degraded. Here is the climate risk assessment. I will leave you with Solange. She will carry on the rest.
We put together a climate risk statement for the Candle Factory in Nantucket, and it's located in Nantucket, obviously, and it stands as a landmark of the 19th century maritime industrial heritage. Once central to the island's whaling economy and early industrial candle production, the building now serves as a museum preserving the legacy of Nantucket's transformation from seafaring trade to industrial innovation. Its brick masonry structure and proximity to the waterfront render it particularly vulnerable to the increasing effects of climate change in coastal New England. Modern climate change predictions indicate that Nantucket faces a severe wind and storm risk, particularly from hurricanes and nor'easters. The wind speeds expected to intensify due to a rising sea surface temperature. Current models predict 1.5 to 2.5 degrees Celsius warming by 2050 and 3 to 4 degrees Celsius by 2100, with a corresponding rise in hurricane intensity and frequency. A 1 in 3,000 year storm event today could generate gusts of 157 miles per hour, increasing to 175 miles per hour within the next 30 years as a result of a warming atmosphere. Increased storm intensity, coastal flooding, and saline aerosol exposure will accelerate the deterioration of the Candle Factory's structural and material components. Monitoring data already suggests variable groundwater levels and potential correlations between exterior fluctuations and interior moisture, especially following summer storm events. Projected climate conditions threaten the Candle Factory's roof, chimneys, and masonry envelope. High-velocity gusts can dislodge roof elements, exposing timber beams and interior structures to moisture infiltration. Salinity exacerbates brick and stone erosion and cracking foundations. Increased soil pressure and fluctuating groundwater levels may destabilize the building's base, while repeating wetting and drying cycles accelerate microbial colonization within wall cavities. These cumulative stressors threaten not only the building's material authenticity, but also the preservation of the museum's collections, which are sensitive to humidity fluctuations. Beyond its physical fabric, the Candle Factory anchors Nantucket's collective identity as a maritime community. It embodies the island's transition from whaling to industrial candle production, a process central to its economic and cultural development. Climate-induced degradation threatens to erode these symbolic and educational values. Loss of original materials through repeated repairs or reconstruction could diminish the site's authenticity and sense of place, weakening its interpretive power and emotional connection for residents and visitors alike. In worst-case scenario, without intervention, escalating storm intensity and moisture intrusion could lead to partial or total structural failure, loss of original materials, and irreversible alteration of the site's historical identity. Such outcomes would mark a significant cultural loss for both Nantucket and New England's maritime heritage network. The Candle Factory has weathered centuries of wind and salt with smart, forward-thinking care. It can keep doing so. By fusing tradition with innovation, Nantucket can turn this old industrial landmark into a beacon of coastal resilience, proof that heritage doesn't just survive change, it can lead the way through it. I'd like to talk about the strategy for risk mitigation, climate adaptation, and conservation treatment. First, we'd like to mention that we have vision and guiding principles. The Candle Factory's resilience plan aims to preserve the building in situ, safeguarding its material authenticity while transforming it into a model for climate responsive heritage management. The strategy balances immediate protection, gradual adaptation, and long-term transformation under severe climate scenarios, and it rests on 3 pillars: structural resilience, environmental adaptation, and social continuity. The second step is a short-term strategy of 1 to 5 years, and that involves immediate risk reduction and preparedness. The objectives are to mitigate current storm and flood impacts, stabilize vulnerable structures, and establish data-based risk management. The actions that need to be taken are drainage and water management, install perimeter French drains and subsurface cisterns with smart pumps and remote monitoring. Permeable paving and rain gardens on the south and east sides will absorb water and reduce capillary rise. Dry floodproofing includes applying a siloxane coating to lower brick courses, adding reversible flood barriers to doors and windows, and integrating backflows. Other actions include structural reinforcement, which is conducting 3D structural modeling and applying carbon fiber bands or stainless steel ties in critical zones. Smart monitoring, deploy LOT sensors for humidity, temperature, and groundwater linked to a digital dashboard accessible by conservators and engineers. Community and education, develop workshops and school curricula on heritage and climate adaptation. Use the Candle Factory as a demonstrative site for sustainable conservation. Emergency response framework includes training a small team of first responders from the NHA staff and local volunteers, integrating protocols with the town emergency service. Also, we would like to propose incorporating AI-based predictive maintenance models to anticipate anticipate failure in masonry zones based on sensor data. Also using bio-based consolidants and nano-lime formulations for sustainable conservation treatments is recommended, or something to look into. The expected outcomes are improved performance on the structure and landscape, strengthened connection between heritage and ecological systems, and enhance adaptive capacity of local institutions. Next step is a long-term strategy, which covers 20 to 100 years. And that includes transformative adaptation and heritage continuity. The objectives are to ensure the Candle Factory's survival under extreme climate scenarios like sea level rise and permanent inundation, while preserving its symbolic and educational value. The pathways are divided into different options. We have option A, which is structural elevation. Raise the entire building 0.9 to 1.2 meters, maintaining the original footprint and structural grid. The next option, a buoyant foundation retrofit. Explore hybrid amphibious systems, allowing temporary flotation during storm surges, inspired by Dutch and Japanese models. Transformative adaptation and heritage continuity. Option C, nature-based coastal defenses. Construct vegetative dunes, oyster reefs, and wetlands around the harbor to dissipate wave energy and support biodiversity. Next option, controlled retreat and interpretation. If permanent inundation occurs, transform the Candle Factory into an elevated interpretive pavilion with virtual access and floating walkways, preserving its cultural meaning even after physical relocation. The supporting measures include integrating the building's adaptation plan into Nantucket's Historic District Resilience Strategy, creating a climate heritage observatory hosted by NHA for long-term documentation and research collaboration. Our expected outcomes are guaranteed heritage continuity under future climate extremes, demonstration of innovation in conservation practice, and global model for adaptive reuse of coastal industrial heritage. Conservation treatments include materials and methods, brick and mortar, repoint with breathable hydraulic lime mortars, impregnate porous brick using silicate consolidants, monitor salt efflorescence cycles. Wood and metal elements, apply natural oil-based coatings and corrosion inhibitors, integrate sacrificial anodes where needed. Roof and chimneys, reinforced using lightweight carbon fiber grids, ensure reversible waterproof membranes. For windows and glazing, introduce laminated storm-resistant glass with UV filtration, preserve historic frames through epoxy micro repair. We've identified some stakeholder issues here. We've got this very complex, expensive project and a community that really cares about its heritage and about planning for the future. So it's important to engage the stakeholders, figure out who they are, and start that process early. So for the first short term, 1 to 5 years, the stakeholders' role will be to do risk preparedness, drainage, and monitoring systems, training workshops, and school and community programs. That will be the way we're going to engage them. And there's a list of the stakeholders here that include the town select board, the NHA administration, conservators, volunteers, and some other organizations. The medium term, for the 5 to 20 years, the role of the stakeholders and engage, the main role of this stakeholder reaching out and engagement is to have structural and landscape adaptation, green infrastructure, research partnerships, AI monitoring, and education and outreach. And that includes Coastal Resilience Grant Program, Land and Water Council, the Land Bank, universities, researchers, ICCROM and UNESCO, the Massachusetts State Historic Preservation Office, and a couple of other organizations. For the long term, we want to have the engagement include transformative adaptation, heritage continuity, digital heritage, long-term funding, and governance models. That includes the National Park Service, ICCROM and UNESCO, universities, Ministry of Foreign Affairs, donors, NHA members, landowners, and global funders. For the short term, 1 to 5 years, our key focus will be on immediate risk reduction and preparedness. So I have a list here of the main stakeholders, and the forms of engagement are workshops, public presentations, local grants, school programs, study visits at the Candle Factory as a living lab. And this is the stakeholder mapping and engagement proposal. And I'm going to continue that for the medium term, 5 to 20 years, for the stakeholder mapping and engagement proposal. We would like to focus on structural adaptation and landscape integration. There's a list here of the main stakeholders, and the forms of engagement include research partnerships, international exchanges, educational projects, publications, open environmental data platforms. For the long term, the key focus will be transformative adaptation and heritage continuity. You see the list of the main stakeholders here in the next column. And the forms of engagement include a research consortium, scenario planning, endowment funds, and digital and educational aspects. We have a stakeholder engagement plan that includes workshops and training that will have capacity building for staff, artisans, and volunteers. Public programs that will include educational events, school curricula, and exhibitions on heritage and climate adaptation. Collaborative research, which includes joint university and ICCROM projects, open access monitoring platforms. Policy integration, it includes continuous dialogue with local, state, and international authorities. Funding and partnership includes grants, community foundations, and long-term endowments for resilience projects. Digital and interpretive initiatives, the development of a living lab, heritage model, online observations for public awareness. We've done some stakeholders mapping to divide the stakeholders into 4 groups: high power, low interest, high power, high interest, low power, low interest, and low power, high interest. The high power high interest are our key folks that we need to really reach out to early. And they include the Town Select Board, the Nantucket Historical Commission, the NHA Administration, NHA members, donors, and visitors, the Nantucket Cultural Council, the Nantucket Emergency Management, the Massachusetts State Historic Preservation Office, ICROM, and UNESCO international organizations. So in contrast, the low power, low interest includes students and parents. Thank you for your attention today, and I just wanted to say that this is a wonderful building to study, for us to look at how climate change, this incredibly dramatic climate change that's predicted, is going to affect the building. But as we take this knowledge that we've learned from this case study back to our home countries, we can apply it to those communities, because we are using Nantucket as a kind of a place to study. It has resources and a community that really cares, and then some of our other countries have more challenges. And so this was really a wonderful way to study the issue, and I'm so grateful to ICROM, ICCR, ICR, and ICC, and the Nantucket Historical Association.
Good afternoon, everyone. We're Zone 2. I'm Desley Gardner. This is Julius Ogega, Achinavanold, and Warapan from Thailand. We are looking at Zone 2 from Greater Light to the Pacific Club, which is our focus site for today. Zone 2 consists of a combination area flowing from residential into urban. The topography of our area is slightly sloping, with the main axis along Main Street, and it follows into the South Water Street and Washington Street, where our focus site is located, the Pacific Club. And we are about 1.05 kilometers from the waterfront, and it's a combination of shaded areas with a lot of tree coverage. The winds are persistent and vary from October to April. There's high wind activity. The climate risk factors that we're considering are increased rainfall, increased wind strength, intense storms, rise in land and sea temperatures, storm surge and inundation, and of course, the area does deal with seasonal weather changes. So for us, our mean consistent average slope from Greater Light to Pacific Club is 9 meters. And as I said before, the area is a collection of residential, commercial, urban, public, institutional spaces with natural features such as wetlands and open lands. So looking at the land use area, mixed use, you see a mixture of Georgian era and Greco-Roman style structures within the built-up area, and along the streets you would see a mixture of cobblestone, granite, asphalt, sandy roads, shell roads, and stone slabbing. The combination of the residential and commercial use gives you a mixture of sandy soil as well as imported loamy soil for the gardens in the area, and there's a consistent 10 feet setback along the streets and buildings. And you have a majority of wooden or brick buildings. It's a core area for flooding and high building density and the season population density, but generally dense area due to commercial function and proximity to the major socioeconomic spaces. So the street layout, we have an interlocking grid system where streets all join together and end out at Main Street. We see a common connection between the street flow, and the orientation of the facades vary based on view, access to the wind flow, as well as optimization of your interaction with your neighbor. So the street gradually slopes, as I said before. There's a central town drainage connected between the residential and the commercial spaces, and the site drainage flows the existing sidewalk and hardscape system that defines the streets and the roadways. So for us, we're looking at Zone 2 as a combination space, but we're looking at the flow of the area to our main site, the Pacific Club. So the Pacific Club is a rear pre-fire building, and it has a unique history, which my colleague, Julius Ogega, is going to share with you.
Thank you. I'm going to take you through a bit of history of Pacific Club, starting from 1775. That is what is written there. But from our archival research, we noted that the actual date when the building was constructed, actually it's not known, because we have seen some photos stating that it was built in 1732 and so on. The style has been told to you by my colleague, this is a gardener from Antigua. The building was built by William Roach. William Roach was a businessman, and he was a great son of Nantucket. And he built it for commercial use, and he was using it as a counting house. Then the Great Fire happened, the Great Fire of 13th July, 1846. When the Great Fire happened, the building was almost destroyed by fire. Then a commission was formed, which looked at the cause of the fire and made some recommendation. And you can see from the map there, that is the map which came from the recommendation. Yeah. So you can see our building is actually number 9. Written number 9. That's right. That one there. And it was affected by fire. And the ones shaded blacks, all those who were affected by fire. And from this, you can see they made several recommendations that the streets needed to be widened. And in the next slide, you'll see how the original design of the building was changed. As you can see, pre-fire, that was the house. Then after that committee made some recommendation, you can see the door now we use as the main entrance today was added. So I think maybe it was added because they wanted to create more fire exit for emergency and so on. The windows were changed. The roof was changed. The window work was also changed. You can see in the first one, the window work was very big and large. Here it was reduced. So the fire affected the building, and I think even the fabric was changed. Next, William Roach sold it for it to be used as a custom house. And when he left Nantucket and established his business in Bedford. So it was used as a custom house, and it continued to be used as a custom house up to 1900. Then the willing members who are going to Pacific, in 1861, they were interested in the house and they purchased it and used it as a meeting house where they can tell their stories of the great adventures going to Pacific to do whaling. By the way, do you know this is not the only Pacific club we have? There is a Pacific club in Hawaii, the same name, built in 1851. So we don't know how maybe these people from here borrowed the name from Hawaii, or it is their people from Hawaii who borrowed from here. There is also, I've learned there is a Pacific club in Thailand. Yes. So we need to know who borrowed from who. So the welding members used it as a club, and in 1890, it was used as a weather station. And you'll see from the next Yeah, you can see from that photo. It was a weather station. So it was used from 1890 to around 1904 as a weather station. Then, when the last members of Welding Club, the last one, I think, he died in 1913, and now it was also sold again. And during that time, it was being used as a custom house, and later it was also used as a courthouse, district court of Nantucket. All this means that the house was supposed to be changed to suit the purpose. If it was a custom house, maybe they were doing some adjustment. If it was a courthouse, they were doing some adjustment. And you can see that is when it was being used as a court. And when we went there, and we thanked the owner because he allowed us to access the building, and we saw that where the flag is still within the house, though there are some modification which has been done. Today, there was some renovation which was being done, and the house is also very unique because the oldest artwork done by women is found in this house. So this house is very unique. These ones you can see they are still there, though they are in a very bad state. They need some restoration. I'll take you through the values. One is the architectural, aesthetic, and artistic value. As you are told, this is a Georgian neoclassical design of a house. Though when it was built by William Roge, we have not seen the designs we used. The other value is the historical value. I think this is the most important building in Nantucket because of the history from 1700. You see? From 17, we have seen some photos, 1732, others are saying 1775 and so on, being a district, custom house, accounting house, a members only club. So all the history of Nantucket you'll get in this house. Then it also have material value, like the materials which have been used, and also the social value. Thank you.
Okay, so before getting into the building, let's see the stakeholders, which is very interesting because we have everyone over here. So the main actors, since it's a private building, the main actors, of course, would be the owner of the building. And since we have further plans, since it's in a city center, we have a couple of further things to be done on the payment. So we have more actors into this, such as the landowners, the town of Nantucket, the police, and these are the people who have the authority, who are interested, but also have the authority to take decisions. And next, we have people who have interest into the property, such as ICROM, ICR-ICC, architects, Cost to Resilience Advisory Board, and we have NGOs like Maria Mitchell and Linda Lauren. And then finally, the right holders. So we have the tour operators, the NPT, Nantucket Preservation Trust, the NHA. NHA is here, and as well as, I think, in all the three layers in this one. And then we have the community, the bank, which actually operates there, then the tour operators as well. So a general characterization of the Pacific Club, as Ogega has mentioned, we are very not sure about the construction date, but we're going to go with 1775. And it has been rebuilt and adapted multiple times. The architecture has changed. There are a lot of additions and subtractions and all of that. Then the primary materials used are the bricks, which are hand pressed, which we could see in the as visually. And then they have used the mortar, lime plaster. Then the brick has been laid in common bond, which was a very common bond that's been used during that time. And then we have in this, the specialty would be, I guess, the sandstone lintels, because that's only being seen in the southern elevation, which used to be the main elevation back in the day. And then we have wooden corners and dentils. The surface characterization would be the brick, which has different layers, which different colors. We have brick red and black. That apparently states about the hand-pressed brick, which used to be back in the day. The architecture style is a combination of the Georgian and Greek revival period, though it used to be symmetrical back in the day, but as the building started, as people started using it, they had different requirement, and they have changed it over the period of time. So the symmetry is still there, but it's not as it used to be back in the day. So the material characterization, we have, as we talked earlier, the brick, wood, sandstone, glass, copper, and even we have cobble stone in the basement. So these are the couple of materials. So what we did is we did a detailed analysis of materials and condition mapping of all the three elevations. So we have got drawings from the 1969. So what we did is we had a lot of archival information. So we really wanted to compare it, what exactly happened, what was back in the day and what is right now. As Ogega has mentioned, the architecture has changed. So for the moment we went to the site, we were able to see the palimpsest of such as this one. So we were wondering what it was, but then we actually get deep into the archival, and then we realized that that used to be a window back in the day, and then they have actually covered it. So, but we still do have the palimpsest, and then the addition of the earboard, which we thought that is it's really 1775, but apparently it's not. So it makes sense because it was not added in 1969, so they might have added it later. And going into the climate, the condition mapping, our major issue before getting into the basement, we thought that it might be the tree, because we had our major issues were because of the tree, such as the biological growth. Because of the tree, there were a lot of debris in the gutters, and the water was not going down. And since there was a tree, it was not getting dry. There was always humidity out there. So there was a lot of biogrowth on the right side, and which is continuing on the ground floor as well. And they have also done the plaster pointing, but we guess that it's not with the same material. So there is a color difference in it. And then there is a salt crystallization as well in this elevation. Now moving into the south, again, we did a material mapping in here. We could see that the rainwater pipe was added later. There weren't any, there was only 2 rainwater pipe back in the day, and the ventilation, the material has changed. So in the previously all the fenestrations were made up of the wood, but here they have eventually changed that, and they have closed one of the ventilations in the down with just wood. So there's only one left out. And when we went to the basement, we still were not able to figure out where exactly the ventilation was. We were not able to see it from the basement, nor we were able to see it from the ground floor. So that was interesting. And this is the condition mapping of the south wall. Again, our major issue was the sandstone. It's deteriorating, but also the top part of the sandstone, we think that within a couple of years, there's a chances that it's going to fall down. And the other interesting thing was the salt crystallization that we were able to see in the ground floor. It was continuous. It could be because maybe when it snows, they actually put the salt. So maybe because of that, it might be causing just only in the ground floor area. And again, the mortar loss, and so that's interesting. I think that might also be because of the later pointing that they have done, and maybe some material composition issues. The north wall in here, if we actually look from the map, 1969 to 2025, they have actually done quite a lot here. So we were also interested to see this one. We had no clue what it was. We had our own theory, but thanks to Pen, she actually told us before when it used to be a warehouse, what they did, it's like to get the material, they used to pull it. So it was actually an opening, and then they closed it later on. And another interesting part is it used to be a window here, but which they have later opened it for the bank, and it has become a door. And a lot of additional elements. And back in 1969, they didn't had rainwater piping, which they have added later on. So now we have all those elements. Again, in this elevation, the major issue is still the tree. We are not sure if the roots are going, into the building, which it's a possibility. And due to the water dampness, we have a lot of vegetational issues in the ground. And the same, again, in this one, we could see that the gutter is deteriorated, and the gutter is made up of wood. So evidently, when we actually look into inspect all the sites, this is the only site where it's evidently deteriorated. So this is just a photo of like how it's in the attic. We have quite a lot happening here. I think they have actually changed a couple of wood, couple of rafters, but most of them are old woods. And there is this space. So this is also interesting because before meeting Pen, we had our own theories, multiple theories, like it would be for this and that. But she said that after the fire, they had the wood, what they actually were used for reconstruction was, the size was not enough. So whatever size they had, they actually constructed with it. So that's the reason there is a gap. It's a very simple thing, but yeah, it's very interesting how we went through the process. Oh, the most interesting part of Pacific Club, the basement. We only have had 5 minutes, Glenn. So yeah, we would really want to go back there. The problem was within 5 minutes, whatever we could gather, we just gathered, and it's quite a lot happening there. A lot of conditions, and everywhere it's conditioned. You could see it's full colored. So we really don't know. Without the testing, we can't say what exactly the issue is, but we were able to see a lot of black color, maybe a liquid sort of a thing, which is like biogrowth, and then there is a yellow sort of a thing, which initially we thought it might be mud, but Laura said that it's not mud, it must be something related, something else. So again, I think it's in the testing process. The materials on the basement are basically the flooring is of cobble and brick, which are, again, it's not in a very good condition. The wood are also deteriorating, though this one I think is just the dampness, but we really don't know. I mean, what exactly is happening inside? Again, a lot of testing is required. The walls have a lot of sand efflorescence, again, not in a good condition. So basically, it's actually a laboratory, I would say, because a lot to look into it. So this is just an initial assessment. A lot of things has to be done in the basement. So this is the photo. So this is the black color I was talking about. And another interesting thing is that we thought that only the west elevation would have the roots inside, but apparently the south also has a root. So this is the south. And there are a lot of roots it's going, so we have no idea where it's coming from. It would be very interesting to see exactly the root from where. Maybe it might be from the west elevation, the tree which is there. So that was all about the drawing. Then we actually did a condition analysis. We have put together everything in a table format where we analyzed each issues and the problems that it is causing and the effect that it has on the material. For example, efflorescence, the moss, the brick erosion, the color variations of mortar, the rust stains, which again affects the elevation, the aesthetic of it, and the insufficient drainage system, how it's actually affecting the rest of the materials. The same process, so every cause or the condition has been analyzed, and then how it has been affected on the building material has also been done. So these are a couple of photos. So this is the deteriorating sandstone that you see in the left side, the efflorescence on the ground floor, the drainage and moisture issue. Because I think because of the leaves and the water are not coming down. And if you could see in the right side, the gutter is not attached to the wall. There is a gap and the water is leaking. And since the water is leaking and the tree is there, it's not drying up. And again, because of the humidity, the vegetation is going biological growth and issues. So field survey, we had a couple of them. So before getting into the basement, we thought we would do a lot of testing in the the elevation. But since we went to the basement, we wanted to do a lot, especially the ground penetration radar, to see the root system and locate the historic cisterns. Then we want to monitor the water level in the basement, because once we went there, the water was drained out, so we have no idea exactly how much the water level was and how it's increasing, with respect to the flood as well, and if the salt is coming in and what are the levels of it. So it will be very interesting. Over a period of maybe 1 year, it could be tested with respect to the flood and with respect to the flood and the salt increase, maybe every month in one particular date or something like that. Then infrared, for dampness, for moisture. So we would like to do all these testing. Yes, we did. We had got the results of the vibration, but we were not able to find out a very a drastic a note from the test. So we would like to study in a little more detail into it. These are some of the laboratory analysis that we would like to do, like testing the biofilm and mortar petrography to assess the lime salt, and also do testing of the the lime mortar, because both are of, we think that's a different composition. We don't know if it's working or not and which is best. So it would be for the next stage. Yeah, these are some of the examples. Well, this time we actually did a mallet testing, which was very interesting to see the dampness, and then moisture testing and petrographic testing, as I mentioned earlier. So yeah, the treatment priority, our first priority obviously would be our basement, and then the replacement of sandstone, and then addressing the drainage issue, then the cleaning and maintenance of gutter pipes, which has to be regularly, it cannot be just one time. And then consulting an arborist to access a root system, what exactly is happening. And that would be our priority A. Our priority B would mostly be about the mortar loss and then replacement of deteriorating wood. We don't have much of deteriorating wood in the elevation, but we have, I think, a couple of things happening in the basement, so that would be it. And then addressing the biological growth. The C is mostly about aesthetics, so removing those nails that's actually in the elevation, which is creating stains. And then painting of wooden elements, mostly the fenestrations. There's a lot of paint chipping is happening. And then the amazing part, the relocation of electrical conduit, because it's the north elevation. It's a touristic place. People see it, so it doesn't. It would be nice to actually move that to some other place. Okay, now we'll talk about the values and attributes of Pacific Club that's impacted.
Yes, understanding our condition assessment so that we can also evaluate what could be the possible hazards that are impacting our attributes. So we're looking at increased precipitation and freeze and thaw cycles. So when thinking about the affected attributes, brick mortar and the mortar joints, the sandstone trim, as well as the potential impacts of these with accelerated spalling, salt effluence and cracking, deterioration of the architectural value will be a result of this. And then when we think about coastal storm surge and how it will impact the facade, the window frames, and the roof structure, the water infiltration, increasing biological growth, and of course, further sandstone erosion. And that's going to weaken our aesthetic value and authentic materials as well. When we think about humidity and temperature fluctuations, we look at the affected attributes of the interior wooden elements and stored goods on the second floor, because it is currently an antique store and we have to think about the different elements of those that business, and then also potential impact of moisture damage due to the humidity and temperature fluctuations, as well as sea level rise when we think of groundwater rise as well for the basement area and the foundations that could be affected by the roots, and then salt migration into the masonry and capillary action. And the long-term effects of this will cause loss of structural stability and historical fabric. And then, of course, extreme heat and UV radiation causing impacts on the exterior paint and surface finishes of this building, once again affecting our aesthetics. So for Zone 2, when we look at projection models, when we think about the storm tide trends, we already see that the Pacific Club within 8 feet of water would be inundated. And then further into looking at the inundation maps after Category 1, 8 feet of water, once again, we have been inundated. So for us, our assessment would follow a number of monitoring techniques, assessing the wind direction and speed using ultrasonic anemometers, and then assessment of the sun activity when we're looking at the southern elevation that doesn't have a tree, but we're looking at how that exposure would affect the sandstone. And then, of course, evaluation of rain and flooding and humidity analysis within the microclimate of Zone 2. So for us going forward, we're looking to develop a short and long-term goal because we want to improve on our monitoring so that we can eventually develop a disaster management plan around these defined goals and develop an understanding of the changes in our climate hazards. So we're going to be looking at a number of climate scenarios for the Pacific Club. So our main focus is going to be on storm surge and inundation, looking at sea level rise, flooding, coastal erosion, and precipitation. So these are hazards that we think will directly affect the Pacific Club within this zone. So the global mean sea level projected for this area will rise up to 1.0 meters. And then when we think about flooding events are projected to increase in frequency by 40 to 50%. And then for coastal erosion, up to 1,350 feet of the shoreline will be retreated by 2100. When it comes to precipitation, the historical trend from 1995 to 2014 averages to about 20 meters, but in extreme event that goes up to 200 millimeters. And the intensity of these events grow greater than 2.5 meters in a standard deviations above 1981 to 2010. So we see that it's projected by 2100 that we'll have a steady increase in sea level rise. And already we will be inundated by 2100. So it's not looking too good for the Pacific Club. But precipitation increases are continuing as well for the area by 2100, and we see it further increasing gradually every 20 years. So for us, we're looking at high tide flooding. We're also assessing the tidal stereodynamics and trying to understand the storm tides and the surges for this area. And what we're projecting is storm surge and inundations are focused. We're looking at flooding, humidity, heavy rain, wind energy, the freeze and thaw of our materials, and water damage, because these are vulnerable areas and these will directly affect the key exposure areas. So for us, Zone 2 has a medium slope of 13 meters, and the area around the Pacific Club has a medium height of 8 meters. So in 100 years, the site is highly susceptible to storm surge and inundation. The current projections note that the site is susceptible to inundation that will be impacted by just a Category 1 hurricane. So the location of the west elevation at the bottom of Main Street slope exposes the building to much of the storm water escaping the higher slope from the areas like Greater Light. So we have the inundation of the sea level rise and then all the runoff water from Greater Light, which is at a higher slope. So we are in double jeopardy. The basement and ground floor levels are heavily exposed, along with the exterior surfaces such as the brickwork, the guttering, the deteriorating sandstone, the doors, and the windows. So for us, Our projection is the site will be inundated by 9 feet of water due to increased rainfall caused by 40 to 50% of strong frequency within the site by 2100. So for us, when we're looking forward, our action has to start now, or else this will be our fate. So we wanted to have a closer look because this is actually just looking at the exterior, but we have a further interior problem. When we look at the basement water level precipitation levels, we see a steady increase of the water levels, especially when we've had heavy rains. So for us, the key observations are we saw a steady decline in July to early September in the water levels to about 240 millimeters. There's very little rainfall during this period, so the basement water likely drained or evaporated slowly. So the rain triggered spikes from mid-August to mid-September, and each rainfall event corresponds to a sharp rise in the orange line previously shown here. So the partial recovery came in October, which we're in now, and the water level rebounds around 300 millimeters before it was recently drained. We're also looking at the basement water level to CF soil moisture level. So during mid-September to early October, the wall water level, where the black line is, fluctuates between 230 millimeters and 300 millimeters, showing a pattern of periodic rise and fall. So the soil water content increases notably when water level rises, especially in the deeper layers from 30 to 60 centimeters. So for us, our main thing is by early October, water levels were spiking again to 300 millimeters with all the soil layers showing a corresponding increase in water content. And this image here showing you after the water has been drained out, you can see remnants of that soil. So the correlation between rising wall water level and deeper soil saturation implies hydraulic connectivity, groundwater, or infiltration feeding into the basement wall zone somehow. So we have questions. How does the water and precipitation levels interact? Does the basement also receive water from the seawater table? Should the water salinity be tested at each spike? Is there a considerable drop on September 14th, and what caused this drop? Because we learned that it was not drained. And then soon after the rainfall, between the 17th to 24th of August, there was a considerable spike in the water level as well, despite it dropping before the significant rainfall. And does the fire cistern, which is right in front of the Pacific building based on historical maps, does that contribute to the basement water? Which is why we asked for ground penetrating radar to be able to analyze that. And then we also want to know what's happening with the ventilation. So we're just looking at our daily precipitation levels to see if that also could have been impacting our levels in the basement as well. And what we realized with our site is that because these things are currently happening, we're not looking at long-term planning. Our climate action and mitigation will start now. So we're going to look at the climate risks for Pacific Club.
For the climate risk statement, the Pacific Club of Nantucket Island faces critical threats from the climate change with storm surge, inundation, and sea level rise. Sea level rise projections indicate that water levels could increase by up to 9 feet by 2100, and with 40 to 50% escalation in flood exposure, with 1.77 feet below current sea level. These are storm surge and tidal flooding, which threaten to undermine the foundation and accelerate decay in key materials, including wooden structural members, brick masonry, and impermeable floor surfaces. These environmental stressors are already intensifying material deterioration, notably the sandstone erosion on the south elevation, weakened brick masonry and plaster loss on the west, and moisture retention and biological growth on the north facade of the Pacific Club. Sandblasting interventions during the 1960s have further compromised material cohesion, leaving the Pacific Club a highly exposed heritage assets, and existing vulnerabilities includes insufficient local data on climate impacts, fragmented conservation and adaptation frameworks, and institutional coordination for integrated risk response without urgent and collaborative action, including structural reinforcements, comprehensive drainage planning, and a disaster management framework for the area. The Pacific Club and its surrounding historic fabric face progressive material loss and potential loss of historic value by 2100. Proactive measures toward climate adaptation and community-based resilience can safeguard the Pacific Club's physical structure while preserving its role as a symbol of Nantucket historic urban identity and cultural continuity for the future generations. The next slide will be the Pacific Club stakeholder mapping. We have high power, high interest, high power, low interest, low power, high interest, and low power, low interest. Start with high power, high interest, will be Town of Nantucket, Department Division of Climate Resilience, owner of building Nantucket Historical Association, Coastal Resilience Advisory Committee, with high power and low interest, bank and funding institutions, landowner, national park, project funders, government authorities, and low power, high interest, Nantucket community, historians and researchers, tour operators, Nantucket Preservation, Nantucket Conservation, Nantucket Civic League, and NGO. For example, UNESCO, ICROM, link partners, and media. For low power and low interest will be visitors, tourists, taxi transport operators, general public, and emergency management. For mitigation measure, we have installed flood barriers and black fall preventers to control water entry from storm surge and tidal flooding. Develop a community-based disaster preparedness plan and evacuation protocol for the historic waterfront. Develop heritage management plan for historic district of Nantucket. Develop and put in place regular maintenance of building and use deployable barriers at doors and windows during hurricanes. Reinforce wooden beams and foundations using water-resistant anchors and elevated supports. Create an emergency evacuations signage and salvage plan for Pacific Club and neighboring heritage buildings. And also install temperature and humidity sensors for early detection of microclimate fluctuations. Apply breathable lime-based blenders and waterproof coating on brick and sandstone facades. Improve surface and subsurface drainage system by installing French drains and regrading slopes toward street gutter. This is the example. Improve surface and subsurface drainage system by installing French drains and regrading slopes toward street gutters. And Leslie will wrap up.
So our measures are quite proactive, and we're looking towards climate adaptation and community-based resilience, which is why our mitigation methods started for Zone 2 and then also specifically for the Pacific Club, so that we can safeguard the Pacific Club physical structure while preserving its role as a symbol of Nantucket's historic urban identity and cultural continuity for future generations. And for us as young professionals, we are so grateful for this opportunity, and we want to thank the NHA, ICROM, ICR, and ICC. But we want to thank you for this opportunity to expand our knowledge and develop ourselves as young professionals to deal with something that is happening right now and provide actual solutions. And we have been Zone 2. Thank you.
Thank you.
And yeah, a special thanks to Essie and Laura. Thank you so much.
Thank you.
Good afternoon, everybody. We are Zone 3, so we're going to wrap everything up. We were informed by this lovely gentleman, Rohit, that we should do a slight summary for this afternoon. So thank you so much for staying with us this afternoon as we've moved through, well, we're going to get to our third building now, or our third site. You might have noticed that, well, you will notice with us, while we were given different zones, and there have been various, varying hazards, conditions, there are also some similarities. So typically, our first building, or in the zone, we would have a building that's raised, typically made of timber, construction. And then we'd also have a building that is red brick, and then it would have a timber internal structure. The zones and the respective buildings are under imminent threat from climate change. And in the case of Nantucket, this happens to be at an alarming rate. Looking at the area holistically, there are some very subtle similarities that have already occurred. And as a collective, whether it's intentional or not, all three of these sites have started to adapt. Adaptation is possibly now part of heritage in Nantucket. And change in programs, some change in material elements, and even orientation. Keeping in mind, keeping each of these buildings relevant in a contemporary culture, what we anticipate for all of us as we continue to succeed in mitigation and adaptation is a collective effort would be needed to ensure the longevity of Nantucket. So with that being said, not to get emotional, but let's get into Zone 3. So welcome, this is a really nice photograph taken by myself. You are welcome to use it, but please, terms and conditions apply. Yeah? Yes. So, thank you. My name is Lauren Buchanan. I'm from South Africa. I've got a background in architecture and geography, and then I'm a built environment specialist.
Hi everyone, welcome and thank you for coming here. My name is Alessandra Sprega. I'm a conservation architect from Italy, but I live in Los Angeles now.
Hello, Nantucket, Wagwan. I'm Winston Abrahams. I'm from Jamaica, and I'm an archaeologist.
So we've given you a brief introduction to the zones. We will go into more detail. So here's a beautiful old map of Nantucket. I would like to say not much has changed, but actually in reality quite a lot has, and we anticipate a lot more will.
Okay, just to give you guys an overview, we've seen lovely presentations from Zone 1, highlighting the Candle Factory. We've seen a wonderful presentation from Zone 2, highlighting the Pacific Club, and we belong in Zone 3. So that's the southernmost zone, and we extend from the Old Mill to the west, going east to Thomas Macy Warehouse. Now, in terms of the zoning, as you can see here, the building actually sits in the commercial zone, which is highlighted in the red. This historic district is in the blue, light blue. All the areas pretty much susceptible to the elements. However, we are much more at risk based on our location. Land use. Similarly linked to zoning, wherever what you should do is depending on the zoning. So we've seen that most persons are complying as it relates to this. Now, in terms of the historic inventory, these are all the historic sites that are located within our zone, Zone 3, highlighting, of course, the old mill. We looked at that site as well, but our main focus is the Thomas Macy Warehouse. It's significant because of its architecture, art, commerce, industry, and its maritime history. Now moving to street trees or vegetation. That's very important. There was a study conducting, highlighting these historic trees, which were the honey locust and the American elm.
And as you know, trees are very important to urban areas. It provides shade for one. It also helps with air quality, and it's also good for climate change. It's one of the things that we can use to help combat the effects of climate change. Topography. Our area pretty much not really flat. There's a elevation on the western side with highest point 1520 millimeters. Our lowest point is coastally 610 millimeters. And there's a ridge located on the eastern side. And that runs from zone 2 into zone 3. And this is an area of higher elevation. And as you can see, this is an area of lower elevation, which typically will flood a lot more or a lot easier. Now, looking at the cross-section elevation across the zone, so heading from the old mill seaward, you can see it's gently sloping as you go east, and using Greater Light as a reference, you can see where that ridge is once again. So you see that sudden drop off into the lower areas.
So we're going to now go specifically into the Thomas, or into information, or on the Thomas Macy Warehouse. So located at 12 Wharf, the 12 Straight Wharf. It's in the Nantucket downtown, and the building was these kind of conflicting reports. So we had the Great Fire in 1846, the July, and construction started sometime in 1846. It was concluded in 1847. The building is included on the National Register of Historic Places, and then it also forms part of Nantucket's historical district. So it was included on the register in 1966, which I would say is substantial. It's a substantial duration. And then historic values are found in its connection with the whaling industry, which is synonymous with the island. The building program is also, originally was linked closely to the whaling industry, so for whale oil storage and goods. And the architectural style is that of the Greek Revival. So you might see this, again, similarities perhaps with other face brick buildings in the main road and the historic downtown. But then also, as our colleagues from Pacific Club also mentioned, they have that element in theirs. The red face brick is noticeable throughout this core area of Nantucket. And right. So this building in particular, it's also part of the community. It's been part of the landscape for almost 200 years. It contributes to this cultural value, and then aesthetically as well, but then also with the community identity, and is one of the first industries on the island. And then it also has this beautiful connection to the Macy legacy.
Okay, after I've done like this first part of desk-based research, we went finally on site when we could like analyze more in details like the different material and the condition of the building. And this was the first step to undertake what will be like the climate risk assessment for the buildings. As you can see here in this slide, there is like a collection of different images that give you like a sense what is the character of the buildings. We can see the red brick face that we've seen in other buildings before, metal joinery that express like this industrial character of the buildings, whereas inside we have a timber element that constitute the floor and the internal timber frame structure of the three floors of these buildings. We saw that the attic, there is like some insulation that they were like applying, and also this is nothing. And we can see this one is a cross section of the outside street. Our building is here, and you can see like the treatment of the street, and pebbles, stone, and these like more modern laterals, brick. In terms, after this analysis of the material, we wanted to look closely to the condition. So we we look at the condition through this glossary, and use like some instrument like the crack meter to measure the crack, and also like having some visual observation. And what we can see here, like the major issue that have the main facade of the building is efflorescence. The fluorescence is here. It's like crystallized salt that you can see on the joint of the brick. And what causes this efflorescence? Because it's the water that cannot that crystallize. Breaks what is like the softest surface, and the softest surface is obviously like the brick, and creates like this loss of the external surface, or disgregation, like we can see here in the facade. And this happens when you put like some mortar that is really strong, that doesn't allow the movement of the water. So this is the main issue that we found out. We see also that there are like some punctual like loss of the mortar joints, and some issue like with some fissure in the plaster and cracks. So what also we've been doing after analyzing the condition, take some sampling to understand if what we've seen in the mortar were effectively salt efflorescence. So we took like different example, and also we noticed that the granite lintel and the jamb of the main door was cracking and breaking, and so we took like a sample to see if this was caused by salt as well. This is some picture of us on site, like doing documentation and using different tools, and also like once we got back in our office, in the laboratory. Yeah, like we set up like this with Lauren and Aisa, and Glenn. It was really nice to set up this laboratory, and we could check like the actually, I don't know if you can see here, but like this is like a small strip that show how much salinity it is in the samples that we've taken. And there was a lot of salt, so we were right. We produced some condition assessment drawings of the building just on the main facade, and that just like you can visualize what I've been saying until now, that the most problems that we found was this increased salt efflorescence at the base of the wall, and that we could see also internally, quite evident. There are like some ferrous stain caused by like the metal elements that are like rusting on the brick on the granite surface. And we can see also that there were like some previous repair of different cracks throughout the year. Another problem that we notice is like the drainage doesn't have like a good drainage system, and this like can affect, can also contribute to the increased salt efflorescence in this area. Internally, what we notice, despite again like the salt efflorescence, like the timber structure on the upper floors especially closer to this eastern wall. The timber shows some signs of rotting due to probably to water infiltration that we should be checked and addressed immediately. The decay now, it's not too problematic, but like over time could, if not monitored, could be damaged more. And so the potential threat of this building from this first analysis is there are like some sign of localized flooding that we saw, especially at the bottom of the timber post in the internal, in the interior of the building. There is some wind damage that the sea level rise due to this location, and this is like a picture of an event, of a storm event early last year that shows like the exposure of this building. There is also like the deterioration of hardscape. So what we've been told during our visit here, that it's a practice to put like salt on the sidewalk, and in putting salt on the sidewalk, this could really contribute to the absorption of this salt on the building if there is an episode of flooding. So also there is like micro effects that should be checked, like the difference in moisture and temperature variation inside the building. In fact, what we noticed that the salt were really coming inside the building, and this shows like that there is like a dramatic difference between the exterior temperature and the interior, and the rising of water table. So we suggested like some specific treatment to do immediately to address this problematic. And what is like our first priority is the salt efflorescence and the rotting timber. And to eliminate the salt efflorescence, we suggested to clean the surface and also to do some to put some poultice material to just absorb all the salt and keep monitoring. Whereas for the rotting timber material, long term could be like a replacement of the damaged part. But for now, we advise to just identify the moisture ingress, to do a roof inspection, and also to check if the resistance of the timber is still sound. Other priority on the building, there are like some minor crack, are not structural because they don't seem that to come like across the wall. So are like, but should be monitored. And after, for an aesthetic reason, like we suggest repointing them. And for the ferrous staining, this is not a high priority, but it impacts on the aesthetic on the building. So what we suggest is just to do like a cleaning and maybe like to avoid the rusting of the metal element, just to treat them with a product for the anti-rust. Also, of course, what we're suggesting is to put in place an environmental structural monitoring system. We can use like some simple, this is a crack meter, so you just put it on the wall and check once in a while how the cracks move. Usually during a cycle of dry and wet weather, because the crack is when they move. Thermal camera can show like the difference in temperature and when there is like a water infiltration. This we will use for like check the infiltration in the roof, and a moisture meter. Finally, ICR kindly provided like different data that have already been collected in the past years on this building. One about the vibration. And it was interesting to see that there are like some moment on time. This was the analyzing August. that there is like a peak on vibration, probably caused by the traffic. However, we weren't able to see what was the threshold to understand if this vibration can structurally impact the building. But like we can see that, of course, like the measure is far above the human comfort that is suggested. So like this vibration can be problematic, especially for the human comfort, but we don't know at the building level in terms of structure. We were like just comparing like different high activity days. August, it's like high season month. There are like a lot of tourists, so probably like traffic, it's more, there is more traffic during this month. Another things more really interesting. So ICR has already like put in plan an environmental monitoring that consists on 3 humidity and temperature meters that are put, one in the attic, one in the wall, in the south wall, and one in the space between the floor and the ground. And also there is another tool that is in the soil to measure the humidity and temperature of the soil to see. And what we've done with this data, so this is like all the data from those tools at the building level, and we wanted to compare this graph with the atmospheric and vapor air temperature and pressure temperature that we gather from the weather station that is here in the harbor. And we could see that like while externally there are like some drop on temperature and in vapor pressures, internally seems more or less more moderate, no? Sorry, the English.
Constant.
Like constant, thank you. And we have like a drop here around October 3 that like it's the same that is reported here. So probably there was a drop of temperature there, but like the building performed better.
Okay, thank you. So we had chosen specifically sea level rise as our primary hazard, but then related secondary hazards would be the shore level change, the coastal flooding, precipitation, as well as increasing sea surface temperatures, and then coastal erosion. So from the data, we saw that historic data from 1965 until present, there was an increase of 300 millimeters of the sea level. And then what is projected by 2100 is that we would probably see over a meter. Now, you would have already heard that in Zone 2. They had also already reported that. Similarly, this is going to affect with coastal flooding, especially in the low-lying areas, so not just here in the historic downtown. And then it's threatening, homes, lives, livelihoods, and then just your general access. It becomes, I know you say nuisance flooding, but it's problematic. Also, based on the historic data, we would see an average increase of 20 millimeters of rain, and then you get some extreme cases where they say up to 200 millimeters of rain. There's also an increase in the intensity of these precipitation events, which could also be problematic. And then we're also seeing a general increase in sea level surface temperature. Sea surface temperature, sorry, and then that is, directly linked to the sea level rise. And then, of course, it might not be directly related to the Macy Warehouse, but typically coastal erosion, and we had already seen that throughout our time here on the island. So these are some of the projections that, so historic firstly, and then projections with our, relatively low, but then also to the extreme of sea level rise. And it is in feet, so actually a really extreme sea level rise. We could almost see, 2 meters, which is, it would be chaos. Similarly, here, so this is the model that we thought was the most consistent, with the highest indicating just under 1 meter. And then the coastal flooding would be one of the secondary hazards that would be problematic for the whole of Nantucket, but especially downtown. And you can see on this map in the red zones, these areas are likely to fall now within a water level or the sea level. So precipitation, again, our projections indicate high precipitation per month. So it was 20 millimeters per month on average, and then an average annual of 130, but then you have extreme events of 200 millimeters per annum. But then what's really quite interesting is the graph on the right-hand side shows the intensity. So you've got these really extreme outliers, and those are going to be really problematic because there's going to be a whole lot of water at once, and that could really disrupt daily life for quite a while. Similarly, like we've just said, the increase in the warming oceans. Again, the extreme being the red right at the top, and that's seeing quite a high increase in temperature. And then lastly, just to look at coastal erosion, it's not just the north side of the island that will be affected by coastal erosion. It will actually be all points of the island realistically. So you've got your barrier that protects the harbour, the natural barrier, that will basically fall away, and I'm pretty sure that we will come into other problems that we would need to evaluate at that point. When it happens, or if it happens.
Okay, this is just, we wanted to, after giving like an overview of how the change in climate pattern would affect the island, we wanted to focus more on our building, and specifically I know there is a problem, but it's the high tide flooding. It's our like a secondary hazard that is the one that is gonna affect more our building. As you can see here, always like from the data of the weather station here for Nantucket, we see the days of an flood, and you can see like how these over time have increased, and this is projected to dramatically affecting more this area, and this is in different color. You can see like the depth of the coastal flood, and in blue is our building here that is gonna like by 2070 really being underwater like of almost a meter, as we said. So this is like the long-term implication due to coastal flooding that can like erode this part of the coast, can damage like in the site level the infrastructure and the access to the buildings, and like our initial like response and adaptation is to produce like a coastal resilience and disaster plans, and also think in the long term the relocation of some structures, roads, and like key elements of this area from another more safe area. This is also like we wanted to analyze the vulnerability and exposure to climate hazard. At first, we did like from a site level, and like the elements that are gonna be more exposed are, of course, in this area, as it's like mostly commercial, are building, storage, parking, accessibility, but also the vegetation and fauna that we showed before in the initial slide, and the transport, because as we know, like this area has like different road that led to the ferry, and are like greater use from the people here in Nantucket. And also what we saw, like I want to focus on the gaps that we notice in adaptive capacity. There is like for historic buildings and our building especially a conservation management plan that includes mitigation and there is a mitigation plan, but it's from 2019, so maybe it should be outdated. And also we suggest to improve the stakeholders awareness response capacity, because for example in our building, but not in different building, we didn't see solution that can mitigate the flood damage in the building, and also the road surface, most of the road surface around the building is impermeable, and the drainage doesn't work, so it should be maintained. At the building level, of course, the external facade, especially in the low opening, is the one that is going to be affected more, but also due to a secondary impact of storm and wind, also the roof structure can be damaged. And also in the building, we didn't see guidelines for emergency, like an emergency exit plan. We don't know if the users of the building are prepared to face a flooding. So this is something to look into, and also a maintenance program for drainage and system inside. Also, the electricity, we notice they're in a bottom part of the building, and this also is problematic. So this is just a visualization of the element that can be affected more and what can produce, in terms of a disaggregation of the material, because the problem is also how long the water is kept in a place, and there is no vents, no drainage, so if it floods, it's gonna stay there for days, and this can increase the damage and the moisture on the elements. Humidity, salt efflorescence, that already are there, they're gonna be just more, and this is perfect for the allow the rotting of timbers due to fungi and insects. So this is our building now, but according to this projection, this is a visualization of how can be, and this is also it's going to impact not just the material, that but also the use of the building, and changing the use and the for example the design of the facade. This can have an impact on the aesthetic value and the architectural values of the building, because this symmetry, it's really typical of this typology, as we've seen from other presentations. So this could affect the overall integrity and authenticity. So this is these things that we had in mind before writing our climate risk statement. So as just to summarize, the things that are going to impact more this building is the sea level rise and an exposure to increasing exposure to intensity of coastal flooding. There are these environmental stressors are gonna accelerate the deterioration of materials that are historic, and the long-term stability and safety also of the structure. So current vulnerability that include salt efflorescence, insufficient localized climate data, limited financial resource, and fragmented conservation and adaptation effort also contributes to this scenario. And so we want to suggest that we should update heritage policy, conservation policy for this building, strategic planning, and community engagement to face this threat. Now we are passing on the proposal at the building level. So something we talk about short term, long term, but I think on the immediate, because flooding is something that is happening probably every year. We saw the image in 2024. Like every building should have like floodgates, sandbags, like these, I don't know if you can see here, but this plastic wrapping of the building just to like mitigate the threat of flooding. Also installing a backflow flow valve and the pumps to eliminate the water can be something, a solution to do now that can help to mitigate the risk. Whereas on the short term, this is like visualization of we can change like the landscape around the building, allow for a more green space that can capture and absorb the water, putting like a collection tank underneath, vents and pump that can capture the water and move it in other spaces, and also like the insertion of alternative source of energy like solar panels that can alimент the pumps around the buildings. Because when there is a flooding, also the first things that cut off is like electricity. So this could offer like a solution.
You started talking. Okay. So then, more on a long-term projection. We have thought we actually came up with a few suggestions, but we haven't included them because they were a bit scary. But probably the reconfiguration of the internal planning layout is relatively realistic. You would possibly need to raise the ground or the first floor up one, and then even convert the attic into a more functional space as opposed to storage. Storage would probably now come down to the bottom, and if those items are flooded, hopefully it's okay if they're damaged or lost. We would also then suggest, installing skylights or dormers to allow for better ventilation and daylight into that attic space, and then also to reinforce the structural framing. Quite often we've spoken in class about Venice, and that this might be quite a new idea for Nantucket to take on. But then also when we raise buildings, we also need to think about universal access. How are all patrons or people going to access these buildings? So these are things that we've had to take into consideration. And then adding of lightweight and waterproof partitions to allow for flexibility. So then at a broader level, we also then looked at the site and the larger context, not just looking at zone 3, but then also zone 2, zone 1, and actually even beyond that. So immediate or short-term interventions, there's no warning. There are no warning signs, so these could easily be put up. Routine inspections by appropriate personnel would be advisable. And then making available information to the public. It doesn't have to be a formal education session. You can have a really nice infographic just readily available for people to make use of. And then what we've actually seen around Nantucket, so these are readily available. This is the sandbags on the right at the bottom. That's along Washington Street. They were preparing for the rain that we had a few weeks ago. And then to the left, I think that's Cisco. Can't remember, but that's a really nice visualization of what we could do to allow for vegetation planting, to not just to stabilize, but then also to allow for a permeable surface. And then in your medium to long term, we would need to look at a more holistic drainage plan. We would also need to look at more different methods for sidewalks and for road surfaces. We would need, and even parking areas, permeable surface treatments. And then also updating of policy bylaws. I'm not too sure how they're phrased here, but then also an ongoing effort to create awareness, to create knowledge dissemination in workshops, courses, symposiums. So you can have like a really, a high-level academia, but actually let's allow everybody to be involved. So it should be accessible. And then, ultimately, perhaps even moving infrastructure. So we noticed that a lot of the power lines are above ground. They're really high up. This is, maybe a visual impairment or, it's undesirable, but if you put them underground, under your roads, is that not actually more problematic, with the flooding situation in mind?
Okay, now to get our project off the ground, we need help. So we'll have to engage some persons, right? So we're looking at stakeholder mapping. Who are these people that have the power, the influence, the interests? So we map those players, so to speak: high power, low interest; high power, high interest; low power, low interest; as well as low power, high interest. So where do you belong? Which group do you belong? There are also right holders, and some of these persons are a bit marginalized, so we want to get them involved as well. So here you can see where we map a few of the players: the Heritage Authority, high power, low interest; high power, high interest, looking at the Planning Authority, low power, low interest; people like the seasonal residents, the local business owners, low power, high interest; tenants, the users, consultants, NGOs, visitors, curators, artists, etc. Now, we need stakeholder engagement, as I said earlier. And these are just a few of the steps that we can use to get everybody around the table. So first, we need to have an overview and proposal, as well as define all the goals, right? Identify the stakeholders, as I said earlier, map the stakeholders, look at their interests, influence, establish timelines and roles, look at resources, build communication plans, monitoring and reporting. So that information needs to be back and forth going. Use the feedback to revise strategies as you go along. And we're going to do this by getting these people into town hall meetings, forming subcommittee meetings and technical groups. Now, not everything going to be rosy. At times, you'll have conflict or disagreements between the stakeholders, right? So we need to build stakeholder relationships as we go along in the process. That's very important. Now, to build relationship between stakeholders, we need to identify them early, understand their needs, and engage in consistent, transparent communication. Actively involve them in decision-making where possible. Deliver on your commitments to build trust. Very important as well. And tailor your communication to their specific interests and preferred channels. So some persons might like information through the media, social media. Some persons might want it through the radio, the traditional means. So we have to tailor how we communicate with each other. We need to identify and understand stakeholders, communicate clearly and consistently, build trust, and manage engagement. Those are the three major takeaways. Now, concluding, it's a collective responsibility that we all have, right? Heritage-sensitive design is very important. Ensure all interventions respect the site's historic character. So you want to stay within those means. You don't want to go outside the boundaries. Funding opportunities. We must always be on the lookout for these opportunities that might come along. We might can get help from FEMA, NOAA, or state preservation grants. Community education. Host workshops on climate resilience and heritage protection. Policy advocacy. Support local ordinances that promote coastal adaptation. Long-term vision. Position the warehouse as a model for climate-smart heritage preservation. And the other sites might be jealous, but yes, our site could be that model site. All right? Governance collaboration. Establish a joint task force between the city, heritage associations, and local stakeholders to propose and implement a holistic, integrated resilience plan.
Thank you.
That's it.
I was saying that this may be a question for a group of people in a couple of years from now, but what we have to do this in conjunction with the building next door and the block. And I mean, one of the descriptions that I saw about, that I heard, I guess, last year about the Pacific Club is they originally thought their flooding was from the tidal flooding, but it's all the water from the top of Main Street that is funneled down. So just saying, okay, we're going to have a drain or whatever, you're going to impact the next building or the road or whatever. So at what point do we do that? Because it seems to me you got to sort of integrate that in fairly soon. Do you understand my question?
So about the source of the water that's basically in the basement of the...
It's not that. We were looking at individual buildings and a solution for an individual building, which could be used for other buildings, but then you have to look at them together, because if you say one solution is to drain the water away from your building,
right.
you're impacting the next one. So shouldn't you bring the community part in sooner rather than later?
Agreed. And I think that, we only had a month here, and one of the things I was going to say was that the amount of work that I think that got done over the course of this month has been astounding, really, to me, and we can go into the details of that. But when we were thinking about what the larger project zone should be, we looked at a topographical map of downtown Nantucket and saw that there was a ridge from the mill to the Greater Light over to the oldest house. And then, then we took that and came all the way down to the water and made the large zone. One of the things, we also had presentations by the Charles Johnson from the sewer department, who's in charge of stormwater management, who also focused with us at the Pacific Club. So, one of the things that we've learned, and we didn't focus on too much here this time, was the fact that, and we although we said it, is that over the course of time here, there's been a sort of a loss of traditional knowledge, and so Main Street that used to be permeable is now not permeable. Streets were made in such a way that they collected water and controlled the runoff. Now, today, sorry if I've upset anybody, but the DOT is just laying more and more tarmac down. They're pitching the water flow into historic buildings. So there's sort of a loss of knowledge that is sort of working against each other and causing damage. But to address your question, what we're seeing is that almost from every road or street that comes into Main Street, Fair Street, Pine Street, all the other smaller streets that then come in and then go down Main Street, all the buildings along Main Street are having their water drainage just come onto Main Street. So, I agree with you totally. It's a systemic issue. I know the sewer department is looking into how do we build and create a stormwater management program that addresses this issue on a much larger basis. The poor Pacific Club is suffering now because of all of this ill-informed decisions that have been making, or siloed decisions that are being made. But the other part of it too is, thanks, as I was listening to you all, I was not only thinking how incredible your presentations were and how detailed they were, but it also reminded me where this all started with the Park Service, the NHA, ICCROM, experts coming together nationally and internationally, and the idea that something could be made of that. We didn't want to just sit there and say, oh, this is overwhelming and we can't do anything about it. So this sort of experiment got started where the NHA, ICCROM, and our group supported UPenn, and we did that large study that we all have talked about. But then last year's cohort and how far they brought that. But this is a whole other step forward. I think that's something you can talk more about. This is something we've talked about publishing. We talked about maybe having a symposium, because I think what we're doing here, that experiment, is really something is new, and you can talk, he knows much more about it than I do, but with the idea of not just understanding the impact of climate change on historic structures, but also using the data that we're generating and understanding the cause and effect relationships so that we can design rapid responses and have a plan for action. So that's a very long answer to your question, but you have another? Or did I answer your question? Okay.
My question or response is kind of similar to the impermeable surfaces and roads, and I didn't realize till I moved to Nantucket how much I love a dirt road. We live off of a dirt road, and we're not close to a flooding zone, but when it does rain, the water's gone. And it's really something I never thought of because I lived in the city where everything was, flooded, but you could see the rivers happen. And recently, one of our neighbors created this really beautiful brick stone type of thing on their driveway, and it looks great when you go up, but it's all of a sudden just a little patch of that makes the water slide, and it's starting to erode a neighbor down the street's driveway, which never happened before when we were all just really simple dirt roads. So it's just a small little thing affecting another one. And I don't know if we could, this kind of information here could encourage, and I know that there's laws and, after a certain point you have to have dirt roads and take them away or whatever the things are. But it seems to me if we're causing these other issues, I don't know if we could encourage more dirt roads and grass and all these like simple things that you were saying we had, and maybe it didn't allow as much of an issue that we're running into now because we want to, I don't know, drive cars faster or something.
In this and other areas too, particularly down at Brant Point, is in talking to the people that are thinking bigger picture, is that you have zoning laws that are not house by house, property by property, but you look at the ecological zone or whatever, and you zone that way, because what it doesn't work. It doesn't work.
Just your first question is that I don't think it has to be dirt. It can be pavement, it can be brick, it can be cobblestones, it can even be tarmac, but it has to be really well thought out, and the capacity of the systems to manage that have to be designed, and it has to be maintained properly, not in silos, but as a coordinated group. One interesting thing is that in our research and over the last 3 years, it became clear that many of the houses on Main Street had permeable basements, so like brick floors that had sand underneath them, and that allowed water to pass. And it was even written in a few locations that some people left openings in their foundations to allow water to come in so that it would drain away faster. Now, almost every basement you go into on Main Street has a poured slab there. So it's taking something that worked and making it not just not work, it's actually causing other problems. Sorry.
No, I mean, I just wanted to add to what Glenn said. One of the things that we have been really promoting in this course is nature-based solutions, the solutions which are not technocentric, which are not just relying on technology, but is really working with nature. And there are lots of examples from around the world which we can get inspired from. And we have some examples here too, which are being now tried and tested. So I think it is very important that we are looking in a different way than we have been looking for many years, where we have really relied a lot that technology can really address it, but this is something that we have to move from. So this also brings us to this whole concept of resilience that we are now really thinking about here. What does resilience really mean? And in terms of heritage, it is also expanding the notion from just looking at preservation, but also looking at how do we transform, and not transform and then adapt. So that means that we have to somehow also rethink about preservation as a discipline. It's not about just preserving the fabric. It's also about really making sure that we also continue to change and evolve, but at the same time, make sure that there is certain kind of continuity. So it's a new thinking because preservation field has been very conservative for a long time, but now we are really trying to move in that direction. The other point which you mentioned, which I think is very important, is different scales and how do you work across different scales, because if we would, and this is what we also do in this course, we look at the material scale, but then we move to building and then to this entire zone. And that's why zones were there to as the starting point, as the larger blocks, and within those blocks the buildings came in, so that we start going from looking at the macro scale and then coming down to the building, so we understand what are those real issues that are not probably in the building or in the material, but coming from the larger surroundings. So these are all very important points. Now the question is, how do we translate that into changing the system of governance? Because governance is so siloed, as you said, that you have to really break that siloed approach to be able to make this work. Otherwise, we can talk about it, but it will not really change things on ground. So, Glenn, if there are any more questions, Glenn, maybe you should make some reflections on this. He always gets anxious that I'm going to put him on spot. But I think, today you should be on spot, because I think
You put me on the spot every day.
Yeah, I know, but I love that.
Me
So.
too.
But why I think your reflection is important is because for years you have worked in this, developing this whole conservation planning from material testing, and really a very systematic approach you have applied in so many projects. And this has kind of been pushing the envelope to connect that to this climate thinking. And this has been quite an interesting challenge. So how do you see now we moving, and how this approach you see has been coming together? I see it, but I wanted to know about you, how you feel about
Don't
it.
leave. To me, like when we started this, I just feel like you're speaking a different language. Like the way this whole sort of language of systematically assessing a World Heritage site, so that that site can be compared to other sites, and so that I guess when people are evaluating giving a site money, they use that as a way, that similar language, so that apples and apples can be evaluated. I just really couldn't, it hurt my head to think, how do we take architectural conservation, which is so systematic in its approach and so detailed and has such, you can't make a decision without understanding the previous, without defining every step of the process. And my idea has always been, if someone asks a question about why did you do something, I could go back to some data or some observation or something that was obvious that led our group to make that decision. And so in the scheme of what you've been teaching, it's hard, it was always really hard for me to fit that in. And at the symposium that we had in December of 2023, it was, I always come back to this, it was the University of Pennsylvania, Frank Matero, who made a presentation. Maybe I'll back up a second. There was a lot of conversation about many different projects, about many different challenges, and there were no answers. There was just like all of these problems, and no one was coming up with a logical sort of a progression of ideas that could lead to a solution that seemed comfortable, or seemed that it might actually lead somewhere that might be comfortable. And then he made this presentation, and this presentation was about a very large area in the Southwest region that had many historic structures in them, I think mostly earthen architecture, but it wasn't really the point. The point was he took a very systematic approach to doing rapid assessments of the whole area, and then dividing that area up into pieces that were representative, then finding sites within those sites that were representative of the effects of climate change, then buildings within those sites that were representative of the materials and the conditions and how they were being affected. And then he made the point that there's really no connection between global warming data and site-specific issues. So he designed this, then they analyzed these buildings very deeply. They understood the materials, the conditions, the cause and effect relations, the priorities. They did testing. They dotted their I's and crossed their T's on those buildings because he knew that they would be really criticized, because if you were going to make any decisions based on the information from those buildings, you had to really be sure. And then designed site-specific monitoring and testing for those buildings. So there were, exterior weather sensors and monitors, piezometers in wells, like hydraulic stakes that go into the ground that measure temperature and humidity at different levels, and then the humidity and temperature inside and outside a building, and then found locations in buildings where they were strategically, there were some questions there, and there were some beliefs that the impact of climate was having that effect on that building. And so sensors were installed in those locations, inside of materials, and then capped so that you were just reading the conditions inside that zone. And so the data that he started generating from that started to bring real information to a very large, looking at a very large area, being overwhelmed, finding a way to kind of understand it, maybe make some early decisions, have some experiments, take it further and further so that there could be a rapid response. I don't know, that's also a very long answer to your question, but I think it helped me as a conservator enter your world.
Exactly. So that's what we are trying to bridge through this, that there is this systematic methodology which is at a very much rooted at a local level, but unless it connects to the larger global data and the global analysis, which is what climate change is all about, then there will be always this gap. And what happens is that people who talk about climate change talk at that global level and make big talks, but then how do you translate them on the ground? And then there are these works that are being done at the ground level. How do we connect the two? So this course, if we have to say in a nutshell, is really this very honest attempt to bridge this gap, which is there between two different scales, which really need to be connected well if climate change impacts have to be addressed. So I just wanted to say that this has been I would say it's an experimental thing that started, but as we progress and we get into the third year, we really see this taking a very defined shape, which is what makes us feel very confident.
I'm starting to feel confident. But the other part of it that was really exciting was, and we started to work with we had a climate scientist last year that brought us a few steps. The climate scientist this year took us a few more steps, and I think she did an incredible job, not just helping each of your individual projects, but helping us too, just to see how, with all the data that we're generating from the sensors here on Nantucket, how can we maybe build bridges to that data that is where the umbrella climate data. And then the question is, if we can build that bridge from the sensors that we're generating information from to the overall data, can we then build a bridge to another community or another area that is not just in our minds similar, but in the numbers similar? And if we can then, the whole conversation then became, we'd love to build this. We'd love not just to be doing this on Nantucket, but publishing and reaching out, and maybe we talked to the National Trust a little bit about maybe finding ways to connect with other communities. So that's where, for me, like, conservation is finally getting connected to a larger scale.
If there are no more questions, Niles, maybe you would like to say a few words to conclude.
Well, thank you both. I have several thank yous that I'd like to make. To Glenn and Rohit, thank you both very much for all your work and your dedication. And what you just spoke about, it's really exciting to see the path that this has taken. and exciting to think about where it's going. So I'm grateful to you both for your significant investment of time and thought and work in making this all happen. To our partners at ICCROM, a partnership we really value, thank you very much for your work on this, and excited to again see where we can take this together going forward. And at ICR-ICC, Glenn, thank you. And I think Laura and Asia might still be online. Laura and Asia, thank you very much for your work during this class and helping us to continue to advance it. I'd like to thank the NHA staff. I know you've met several of them. You'll see some more tonight at the dinner. They've done a lot of work to make this all happen. I know two of whom are over there, Adam and Phoebe. Thank you both very much for your work in pulling this all off. Amy, who I know wanted to be here, had to leave the island, unfortunately, but she sends her regards and did a ton of work to help pull this together as well. And to our board of trustees, who I think took a bit of a flyer on this with us and have supported it to make this happen. As Rohit said, this is sort of a concept that we're testing out, and it's really exciting to see where that's going as well. So to the Osceola Foundation and Remain, who have been two early sponsors of this project, our thanks to you for your belief in this idea and taking a chance as well in making this happen. Lastly, my thanks to the 11 of you who have come from around the world to spend a month on Nantucket. And I know it was a big jump to do that, particularly with all that's sort of going on in this world. So very grateful that you would do it and that you would spend the time to come here and dedicate yourselves in the hard work that you've put in over the last 4 weeks. I'm very, very grateful to that. Excited that we now have 11 new friends, a larger cohort that continues to expand, and very eager to follow your work and your success going forward. The presentations today were fantastic. It's so much work, obviously. I can't wait to really get my hands on them and pore over them and read through them and take those and use those as documents to help us in our thinking. In each of those cases, there's a lot of information and data that will guide us as we move forward. You know that we're already doing some work here on the Candle Factory. We have more to come that'll be guided in part by what you've shared. At the Macy Warehouse, we have some exciting plans that we're beginning to generate for a new use of that property. Having this information will really help guide us in that property as well. And even though the Pacific Club is not ours, as Ogega said, I think it was you who said, it's got to be one of the most important, if not the most important historic buildings on the island, and I agree, it really is. And given the condition, some of the conditions that it's struggling with that you highlighted, hopefully we can help the ownership there and the town make some changes that will preserve it far into the future. So the work you've done, while this whole project has been conceptual, as Glenn and Rohit just said, it's exciting to see it become actionable. And we are taking this and now have materials and information that can guide us along the way. So I'm very grateful to you for that work that has come from this and will really help us moving forward. And then, as I said yesterday, I'm really excited about what we might do together to expand your work and the work of our previous cohort, and to create a system that'll help share your efforts and this material with a larger audience. So stay tuned on that. We'll look forward to feedback from you, getting some suggestions that you might have as we go forward, and thinking about how collectively we continue to do this work to try to improve the world. So looking forward to tonight. Fun dinner, just to have some fun. I think, are we going to catch up briefly right after this? You still want to do it? We get together? Group photo, good idea. Great. Thanks to NCTV for being here and recording both yesterday and today. We look forward to sharing these videos on our website. And with that, thank you, everyone.